Well, good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com program, brought to you by Techstrong and Fairwinds. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting program for you today. First, I do have just a couple of housekeeping notes. So today's session is being recorded. If you missed any of our webinar, or you'd like to watch it later or share with a friend, the on-demand recording will be made available shortly after we conclude our live session today. If you have any question for Kindle and the team, we want you to send those in to us using the Q&A tab, which you'll find on the right side of your screen. That's also where you're going to find the chat tab, and that's where we want you to get to know the rest of your audience members. Let us know where you're from or any comments you might have throughout today's program. And I will also point out that we do have 2 polls we'll be launching throughout today's program, and we really want your participation there. Finally, before we close, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around until the very end. Our topic today is why Kubernetes is the black hole of FinOps, and I'm joined by Kendall Miller, technical evangelist at Fairwinds, Robert Brennan, vice president of product development at Fairwinds, and Rachel Sweeney, insights enablement engineer at Fairwinds. So Rachel, Robert, Kendall, thank you all so much for joining me today. I'm going to let Kendall take it from here.
All right, thanks, Cody. And we will go ahead and dive in. Welcome, folks. This is why Kubernetes is the black hole of FinOps. And excited to have you here. We're going to be talking about what is different about Kubernetes in the FinOps world. That's what the point of this talk is. Why Kubernetes specifically is a black hole when it comes to cost and FinOps-y things. What's difficult about understanding it, what you can do to get around that, and we'll go ahead and dive in. So I'm on a little bit different setup than I'm used to today, so pardon me as I jump things around, but hopefully it's not real obvious to most of y'all. Let's start with introductions. Robert, you want to go first?
Yeah, hey folks, my name is Robert Brennan. I'm VP of Product Development here at Fairwinds. I lead up all the engineering efforts around Insights, so I can hopefully give you all a little bit more insight into how we think about cost in Kubernetes.
Great. And Rachel?
Yeah, thank you, Kendall. Hey, everyone. My name is Rachel Sweeney. I am the Insights Enablement Engineer here at Fairwinds. I'm coming from a background of being a DevOps engineer and then a site reliability engineer before that. So digging into a lot of the technical weeds of Insights and getting it to work in all different kinds of environments. And yeah.
All right. And hey, folks, my name's Kendall Miller. I've been at Fairwinds for 7 years now and kind of done just about everything. Today, I am a technical evangelist and excited to be here and talk with you about what we're doing at Fairwinds. So real quick, about Kubernetes, about FinOps, and what we're doing at Fairwinds, I should specify. Why we're talking to you today. So real quick, Fairwinds is the trusted partner for Kubernetes security, policy, and governance. It's our mission to help companies ship faster with more confidence so that it costs them less, that there's less risk involved. And we build software that unifies problems in dev, security, and operations so we can remove friction from between those two. That's the mission statement. The bigger picture is we've been working in Kubernetes for a very long time. We have built and maintained Kubernetes infrastructure for lots and lots of companies over the years. And when we were doing much more services a while back, today we're heavily focused on software. And we build software to give people confidence that they're using Kubernetes right. Kubernetes is still a new paradigm for most places. So we have built a bunch of open source, as well as a SaaS platform that marries together our open source and some other folks, as well as some other proprietary bits to give people confidence in using Kubernetes. When you make this switch, you want to not have to learn all of the painful lessons of a new paradigm the hard way. So check out our open source on GitHub. We're going to show you a little bit of our software towards the end of this. It's relevant across security, reliability, and then cost efficiency, which is part of what we're talking about today. So we have built a bunch of logic into some of our software around FinOps and managing cost and understanding cost. And that's why we're here talking about this today. It's something we care about. Yeah, so let's start though with a polling question. Where are you in your Kubernetes journey? And we'll pull that up. Are you just learning about containers in Kubernetes? Are you planning to use it in the next 6 to 12 months? or are you already using it in production? And you can fill that out. We'll give it a few seconds here. To know what our audience is.
We need that elevator music at this point. Maybe some Jeopardy theme song. Or Kindle. Yeah, we just have a Kindle. So.
Yeah, sorry. Not quite as exciting as the real thing. But where are you in your Kubernetes journey? Looks like vast majority of you are using it in production. That makes sense. I guess if you're here for a FinOps conversation, it's probably at a point where you're either nervous about using it because you're afraid you can't manage the cost, or you're using it in production and you already know you can't, or you have a difficult time doing this. Kubernetes is very easy to lose the thread on what you're doing with costs, so it makes sense. And this is about the breakdown that we've tended to see most recently. So appreciate that. You can pull off those results. Great. And let's go ahead and dive into our topic today, starting with what is FinOps. So we've pulled from the FinOps Foundation the textbook definition, and I'm going to read this and then we're going to discuss it briefly. But FinOps is an evolving cloud financial management discipline and cultural practice that enables organizations to get maximum business value by helping engineering, finance, technology, and business teams to collaborate on data-driven spending decisions. Holy cow, that's a mouthful, but let's unpack that. Robert, why does it matter that the entire organization understands cost?
Yeah, so I like to think of FinOps as like a natural extension of DevOps, right? At some point in the last decade or so, this idea of DevOps became a thing where you take development and operations and you really get them working well together. In the bad old days, there was too much of a wall between those two roles, and it caused a lot of friction and a lot of problems for the business. So we're seeing the same thing now between finance and operations, right? The decisions that the operations team makes on a day-to-day basis, which are often driven by engineering needs and engineering desires, often, finance takes a backseat there and isn't consulted on decisions that might actually impact the bottom line, impact cost of goods, things like that. So making sure that finance and operations are working together is super important to make sure that, you're making decisions with the whole business in mind rather than, decisions that just think about engineering and how engineering operates. Finance needs to be looped into those decisions so that trade-offs can be discussed between, ramping up more infrastructure and speeding up your developers versus, keeping those costs at a reasonable level and, potentially slowing engineering down.
Yeah, that's part of why this definition doesn't say FinOps is the one-time thing where you drop into an organization, save them $250,000 and move on and never engage over it again, right? This is it's a discipline, it's a cultural practice that is ongoing and enables organizations to get business value. Like I hate that it says business value, but it is the right word in that, what we need is for organizations to be spending the right amount of money, giving finance confidence that that's what it's doing, giving engineering the budget to spend on other things so that it's not overspending, et cetera. So having a practice organizationally of understanding where is your money going, why is it going there, is it going to the right places, if we cut some of this spend, are we cutting it in the right places, et cetera. That's all part of FinOps. And before I move on, Rachel, anything to add to that?
No, I don't think I could have said it better. That was such a good description. I think one of the challenges is so often, cloud spend just increases and it's hard to tie those things back to what exactly the business value is or what the goal you're trying to do is. And so, yeah, I think it's just kind of that holistic view of trying to see how do we tie this all back together to what we're trying to achieve. Yeah,
great. So, why do we care about that? And it may seem obvious, and we've already touched just a tiny bit on this, but why does what we're spending matching what we want to be spending matter? And Rachel, do you want to start with that one?
Sure. Yes, I've worked at a number of organizations where we have seen cloud costs increase, and there's always somebody that asks, what are we actually spending this on, or how do we connect this back to things? And usually the first thing is, I don't know, we have this big idea of like how it should tie back, but pinpointing it down to certain things is a lot trickier. And so if we don't start to take a closer look at those things, that's when things do kind of snowball out of control. And it's really important to be able to focus on, how we are spinning up new resources and compute and stuff and storage, and figuring out how that impacts different portions of the business, and just trying to really focus on, how all that ties to the bigger picture.
Robert, anything to add to that?
Yeah, so I'll say, maybe if you're a small startup that just raised $10 million in funding and you've only got 2 users, and your cloud bills are still pretty small, maybe you don't care. But the second your organization gets to be a certain size, you've got a bunch of users, you've got cloud costs that are substantial, maybe tens of thousands of dollars a month. Some companies spend millions of dollars per month on Amazon and Google, GCP and all that. So once you hit a certain point in the size of your business, it becomes critical that you understand where all these costs are coming from. And very frequently, you will see businesses that once they start to put some tooling in place to understand where are these costs coming from, they realize they've got whole machines that are running that nobody's using. Like there's just a ton of waste in there, and that not only is money that's kind of just going out the door. It can really affect your company's balance sheet too, right? It can look like your product costs a lot more to deliver than it actually does. And that can affect how much investment you're able to get, et cetera. So it can really have a huge impact on the business if you're not, putting some, instrumentation in place to understand, what you're spending and why you're spending it.
And I want to add the other side of that, which is there are some organizations that become so cost sensitive that it becomes 100% about cutting cost, the minimum possible. And there is a world wherein you can under provision all of your things and it's technically working. It's just a terrible experience for everyone. And so, if you don't have visibility into what the right amounts are of the right things, you can be giving all of your users a terrible experience and reporting up to finance, hey, it only costs us this much to run everything, when actually it costs you this much to run it well. And, even knowing that is another important thing. So while most of FinOps conversation is around the saving money side, it's not just saving money. And we have a slide here that says that it's not just cost savings. That's not all FinOps is. And this is a slide that I insisted we put in. And it was at least one person at Fairwinds that was like, I hate that meme style of the clapping between every word. But like, it really is like, it's not just cost savings. Cost savings is a part of what you're doing in FinOps, and making sure that you're saving money in the right places is a significant part of all things related to FinOps. But if all you're doing is cutting costs, you're going to run into other problems. And really what you want is tooling, and you want a practice that enables both increase and decrease where you can, because there are times where you do need to spend more money than you're spending. In the same way that, like, I mean, this applies to everything, right? You go hire the very junior person and they're not solving your problem. It seems like you're spending less, but you're not. It's costing you more. That you drive the 2004 Subaru with flames on the side and a racing stripe down the front, which I may or may not have recently owned. It ends up costing you more than you think it costs you, because it just does not work. You can't sell it for anything. And it ends up eventually, with the mechanic telling you, please never put this on the road again. It shouldn't be legal. And, it can cost you. There are costs in just cutting corners. Before I move on from that, anything to add?
Yeah, that's a great point. One thing that we've had happen a number of times is we've used tooling to work with our clients and actually show them ways where if they spend more money, their infrastructure will be more reliable. So maybe they have an API running in Kubernetes and they don't have enough, backups, or there's not enough, the deployment doesn't have enough pods running, and we would recommend, if this is critical to you, you really should have more. Maybe you should allocate more CPU and memory, because you don't want it to get killed and just be a bad experience for your users. And so those are situations where having FinOps in mind and using tooling, spending more money is actually the right thing to do if that meets your business needs.
Yeah, I think that's a really great point. And being able to quantify those decisions, if we double the number of pods running this application, or if we, add one CPU to every single pod, like this is what it's going to cost us. And, this is what the impact to users is going to be. are really great, ways to go to your finance department or, the head of the operations department and say, here's a decision I think we should make. Here's what it's going to cost us. Here's how it's going to benefit our users. The right tooling can allow you to answer those questions really easily.
Yeah, and that's a key point. It's one thing to be constantly telling your leadership, we have to spend more, things are bad. We have to spend more, things are bad. But unless you can say, okay, we have to spend more, this is how much more we have to spend for things to be better, it's really hard for finance to make those decisions. I have seen, a good friend of mine was an infrastructure leader at a very large publicly traded company, grew it and grew it and grew it and grew it and said, hey, we have to get our cost under control. And leadership kept telling him, it doesn't matter, just spend. It doesn't matter, just spend. It doesn't matter, just spend. And eventually it got to a point where it mattered and they fired him. And he was like, what the heck? I literally said this constantly. So it's a thing that happens, and it can cost you your job in addition to just infrastructure that's provisioned correctly. So the CNCF recently did a FinOps survey, and I guess this was a year ago, but it says among those whose spend increased, whose cloud spend increased, half of companies saw it jump more than 20% during a year. So it's common for organizations to see things go up and lose track of how much it's going up. And a 20% increase, I mean, you can imagine if you're talking about $1 million, that's a whole hire. If you're that all of a sudden is gone, right? Like that's a whole person you could have hired, or maybe many people, depending on how much you're paying for engineers these days, and where they are, I guess. But if it's tens of $1 million, that's a whole lot more. And even if it's just little things like, hey, we also need the budget to buy X, Y, or Z. It's really easy to have costs run away in a hurry. I know we've seen organizations that are wildly over provisioned. Do we have any stories that y'all can share without customer names about wild over provisioning?
Yeah, I do remember one that was running. It was some development workload. It wasn't customer facing at all. It might have been like GitLab, CI/CD runners or something like that. And we could tell from the instrumentation that we put in place that they had asked for, say 2 CPUs per pod on these workloads. And there were tons of them because it was like every CI/CD process or something like that. So these things were constantly running, using, dozens of CPUs every single hour or something like that. And they were only using 1% of what they were asking for. And so we were able to turn that down and save them thousands of dollars per month just from that one workload. And again, with zero impact to customers.
Yeah, I think a common pattern that often happens is, developers, they work with infrastructure, but to a certain degree. And so if they do get something working, they'll talk with another developer and be like, here's the Kubernetes manifest that I used to get it working. I've had no problems. And suddenly it just gets copied from developer to developer. Now everybody has, 8 gigabytes of memory and 4 CPU cores or whatever they might need, that got it working that particular time. And with this move to Kubernetes in the cloud, we have this wonderful ability to auto scale when we need it. And if we are requesting 4 CPUs, but using 1%, like Robert said, Kubernetes is going to be like, I need to give them at least 4 CPUs. And so that's going to scale out horizontally pretty fast. And next thing you know, you have way more nodes than you ever anticipated based on, not right sizing your workloads and having efficiencies quite right. So it was easy for that to run away.
Yeah. Okay. So the FinOps Foundation says the number one problem is getting engineers to take action on the problem. And part of the reason this is difficult is in any sufficiently large organization or any organization that has actually put in place some kind of service ownership being where you've pushed the ownership of a service from development all the way through to production down to the developer's responsibility. Or the people who build it need to own it all the way through production, need to own responding to incidences, et cetera. If you have a sufficiently large organization, you need your engineers to care about this. You need them to be involved in it every step of the way. And most engineers don't know how to care about it. They're not DevOps engineers. They don't know what it takes to provision. It's very easy for an engineer to say, well, it works on my machine. And then they go to the Apple in the top corner of their Mac and they say about this machine, and they look at, how much CPU and how much RAM do I have? Okay, I guess I'll just provision that, right? Like, I mean, it's not that crazy out of the ordinary to think, because it's just not a world they've had to live in. So how do we make that, how do we get engineers to take action? Robert, you want to talk about that?
Yeah, I mean, so this is the whole problem of shift left, right? There are people who are well downstream from the engineers, people working in operations, people working in finance, who are responsible for these decisions getting made by engineers, right? If an engineer provisions, a workload with 16 CPUs or whatever, then, finance is going to find out, a month later, and they need to feed that fact back to the engineers and get the engineers to change their configuration. And so more and more, you're seeing this idea of shifting that information left, so that as an engineer, say, makes a pull request, they're getting that information fed back to them very quickly. Like, hey, you're asking for way too many CPUs. You're trying to do things you shouldn't do. So that way, before the code even gets checked into production or checked into the main branch of the repo, let alone gets into the Kubernetes cluster, your actual production environment, the engineer's getting that feedback and can make those changes, while they're already there, rather than having this month-long feedback loop where, you have to involve other people in finance, operations, things like that.
Yeah, I think of it a little bit as I have 4 children, and taking care of 4 children constantly is complicated, especially as they get older and have more complicated social lives. For years, we have been able to send a kid to go play somewhere, right, with some kind of boundaries around it. Yeah, you can go play as long as you're home by 4:30, 5, right? The problem is they don't have a watch, because they lose their watches all the time. And so we have a rule in the house, like you don't get to play with your friends unless you have a watch. And like, we make them buy the watch whenever they lose a watch, because it's a constant thing. But if I give my son a watch, he can set an alarm. Hey, at 3:15, I got to leave because I got to be home by 3:30. And we can make my kids successful with the right tooling. And, it's the same thing with your engineers. It's not that they want to screw everything up. They want to do it right. They just probably don't know how. And so having tooling in place that's going to help your engineers own this problem is a big part of the reason, or is a big part of what it takes to get them to do it. And a lot of engineers can't take action because they're not enabled to do so. So the whole point of this is, why is FinOps different in Kubernetes? Let's talk for a minute about that. What's different about Kubernetes, Robert? Why is this a bigger black box than previous things?
Yeah, so before Kubernetes, what you would typically do is, if you want to launch a new application, you would provision 1 or more EC2 instances in your Amazon account and deploy directly to each of those instances. And then when you get your AWS bill, you can see, okay, this instance cost me this much money. It was used by this application. Therefore, this application cost me X dollars per month. There's a very one-to-one mapping between applications and items on your AWS bill. What's different in Kubernetes is that now you have a bunch of EC2 instances that basically become a pool of memory and CPU that any application can pull from. And so you might have 3 or 4 different applications all running on the same, actual, EC2 instance that's on your Amazon bill. And so the question becomes, when you get that bill from AWS, how do you take that one instance and divide it among all the applications that may or may not have been using it at the time? So it becomes this weird, black hole in terms of what AWS can see without being able to look inside the cluster and see which applications happen to be running on this node at this time. There's no way to really split up that AWS bill fairly between applications.
Yep. Yeah. The world of owning your infrastructure has changed, and owning your infrastructure to cloud was as big, like having your own data center and moving to cloud was as big of a shift in some ways as going from cloud and directly talking to, Amazon APIs as it is going from that to Kubernetes. And it's just a whole different world. You're defining things in a different way, and Kubernetes can run with it in a different way. And, it's a little like telling a young child, here's how big the boat is, put as many containers on it as you can, and this is what can happen. This is probably actually loaded by significant professional or group of professionals, but runaway whatever is real easy to happen because it's just that everything about it's different. Okay, so talk a little bit more about shared resources, the fact that everything can just auto scale on its own. I mean, Rachel, talk about this. Why is this so different?
Yeah, I think, Robert was touching on it and how, now that we have this pool of resources, we've essentially used a Kubernetes cluster to turn it into one platform to just deploy things. And so if Amazon or Google or Azure is charging us maybe by the minute, maybe by the hour at some rate like that, and we have a team that is deploying something into a Kubernetes cluster, what if they only run their resource for 36 minutes a day? How would you charge them for that? Is it on one node? Is it on two nodes? Is it on the more expensive nodes or is it on the cheaper nodes? There's just so many different things to keep track of. And even if you plan for some of those things, what if it requires, what if customers are hitting it faster and it auto scales out horizontally and now it's just completely changed the calculation? Certainly a lot of people, in the past few years have been like, well, maybe I can just label things and I can script them, but there are all sorts of complications for that, because then how do you think about the unused resources? Kubernetes is all about optimizing that so we're not using more than we need. And there's just so many different problems to think through that make it really challenging to figure out how to allocate things to teams. Maybe if you're at a huge organization, you can just do a cluster for a team, but that is probably not practical for the vast majority of people. And maybe you could cut it up by namespace, but that's still not solving the underlying node and cost problem at all. So there's just so many things to think through with this shift to Kubernetes and how you allocate cost.
I want to ask about that. Kubernetes has a horizontal pod autoscaler. I set some things and I let it scale, right? I suppose I could set them wrong, which is part of what we're talking about. A lot of people do set it wrong, right? There's also a vertical pod autoscaler. Can't I just turn on vertical pod autoscaling and horizontal pod autoscaling and hand it to Kubernetes and everything's going to be just great and fine and dandy?
My first reaction to that is you definitely don't want to use both of them together. Why
not? I mean, talk about why not.
So they're really in conflict with each other, right? If you have a workload that starts getting increased load, starts using more CPU and memory and stuff like that, the question is, should it scale vertically? Should I allocate more CPU and memory to that single instance of it, or should I scale it horizontally and just come up with more instances of it that can spread traffic across all the instances? And that's kind of a design decision that you need to make. How well does your application parallelize? How much efficiency do you gain by having it all running in the same process? That sort of thing. So that's really a decision that you need to be thinking about in terms of how your own application behaves. You also need to provide some limits for that too, right? If you have a memory leak, you don't want the vertical pod autoscaler to just keep provisioning more and more and more and more memory, or you're going to eat up an entire node before your application crashes. You want to tell Kubernetes, this is the maximum amount of memory that my application will use under normal circumstances. If it tries to use more than that, kill it and start up a new one. And then you've got some kind of memory issue, but it's not going to hog your resources in the meantime. So there's a lot of limits you should put in place. A lot of hints you kind of need to give to Kubernetes about what a normal behavior for your application looks like for Kubernetes to be able to do its job in terms of autoscaling.
But Robert, if I've just hacked your infrastructure and I'm planning on doing some crypto mining in the background without you noticing, won't all of these protections in place that you're talking about cause me problems?
Exactly.
Yeah, exactly. That's exactly the point, right? Yeah, there's, and it's not just a bad actor. I mean, the vast majority of the time, the problems come from incompetence, not maliciousness. And it's easy to be incompetent unless you have the right bits there. Okay, what am I not talking about? On the storage side, is there a way to run stateful sets or storage workloads within Kubernetes that get complicated? Is that difficult to track? Like what have we not covered?
Yeah, storage is definitely a tricky one in Kubernetes. We're seeing it more and more. Folks are starting to tackle this idea of trying to run stateful things inside of Kubernetes. But it's still not something I personally would recommend, just because of the scariness of data loss. But it does add to the complexity of billing, right? Storage does cost you money. You probably want to see that, listed out in any kind of bill for an application.
Yeah. Okay. Have we beat this sufficiently? Anything that we're leaving out here, Rachel?
I think so. Yeah, I think we're good. It's a hard challenge to solve without the right tooling. So,
I guess one last question. Did we talk about spot instances specifically? How does spot instances affect, FinOps and Kubernetes in particular?
I think it, just further complicates this problem because, again, if you have a reserved instance, you have a very fixed rate and you know what you're paying. But if you have a spot instance for 5 hours and maybe 3 of your 9 teams use it, it's just like we're adding more variables to this calculation, which is just making it even harder to calculate. And yeah, it just makes it that much harder to figure everything out without the right tooling. And
yeah, so to put a cap on this, I mean, back in the day when you went and bought, a rack worth of computers, you knew what that rack of computers cost you to set up, you knew what your internet bill was, and that was what it cost you to run your application. And it was never more or never less unless you shut off a machine or power went down or something else, or you had to replace a computer. But it was a very fixed set. You knew what that set was. You knew what it was going to cost you. Move to the cloud, and there used to be some controllability when it's just EC2 and you're using something like Ansible and you're choosing, okay, we need to add a couple instances or reduce a couple instances. You have a pretty good idea of what an instance costs. But in Kubernetes, it's very easy to hand over a set of instructions to Kube, let it run wild, and lose track real quick of what things look like. It's real easy to have wild over provisioning. It's real easy to let Kubernetes bin pack inappropriately, over too much or too little, all the way around, and start to cause problems. So the reason FinOps is different in Kubernetes is it's a whole new paradigm. We're literally just declaring. The beauty of Kubernetes is we just declare what we want, and Kubernetes goes and makes it so. The problem is, without some clear directions to Kubernetes, it can mess all of that up. It's a child without a watch going over to his friend's house and completely clueless to the world. So it's real easy to let it run wild. So let's talk. Yeah, I think we've covered service ownership significantly. Is there anything else to add to this? Like we talked, well, maybe not significantly. At the beginning, we talked a little bit about developers owning this. So what does it take for a developer to own this, particularly in Kubernetes world? How do I, as a developer writing code, do something other than click on my Apple button and say, this is how much memory and CPU I need because it works on my computer? The joke with Docker is, it works on my machine became, okay, let's ship your machine. And, it's real easy to do that, right? How do we do something better in service ownership?
I think the big thing is just making sure that information is being fed back to development teams. So they should understand, how much does their application cost as it runs in production? What are the compute costs that it's incurring? What are the storage costs that it's incurring, et cetera? And then also making sure, once at least those raw costs are being fed back to them, so they know, if costs increase by 20% this month or something like that, they can start to think, okay, what might we have done? What might we have shipped that caused that cost increase? It's a great starting point. On top of that, it's really helpful to get some metrics around like, okay, how efficient are they being? Like, is there a bunch of CPU that they've provisioned that's going unused? Is there a bunch of memory that they provisioned that's going unused? Things like that. So you can kind of start to feed back to them, okay, you're costing $10,000 a month. You're really only using like $3,000 worth of that. So like, is there something you could be doing? Is there something you could be tuning better to start saving that money?
Yeah.
Yeah, I think to add to that, trying to get that information into the feedback loop with the owners that are putting that out, I think is the most helpful. That way, if they see this having an impact and they can do something about it without even having to do the extra work to like look for it, I think that's going to make a lot bigger impact. And yeah, Robert talked about, shifting left, which is certainly challenging in a lot of ways without the right information, but that's kind of just getting it into that workflow. So it's right there where you would expect to see it, and it just makes it a lot easier.
Yeah. Okay, great. So a couple things that I want to mention on this. First of all, Fairwinds, as I mentioned, makes a lot of software to give you confidence that you're using Kubernetes right. If we're about to show our SaaS platform that addresses this significantly from a FinOps perspective. However, if you want to take a look at some of our open source, we have a project out there that plays in this space. It's called Goldilocks. It gets your workload requests and limits just right. That's why it's called Goldilocks. Go check that out. It's easy to install it on one cluster, check out a couple of workloads, see how things are going. If you want to operationalize it at a larger scale, that's where our SaaS software comes in and really offers a number of advantages in addition to that. But that's a good place to get started. And that's just, github.com/fairwindsops is our open source repos. So that's something worth going and checking out. But let's dive into Fairwinds Insights, which is software for governance and guardrails from CI/CD through to production. And just at a high level, I'm gonna show it to you in just a second. But as I've mentioned several times, this is a new paradigm in Kubernetes. And for a bunch of clusters and a bunch of teams, managing Kubernetes and containers is hard. And it's hard for organizations to know if they have security lockdown in Kubernetes. There's different security considerations than there are in other things. It's hard for organizations to know if they have the right policy and guardrails so their people aren't deploying the wrong things in the wrong places. And it's really difficult for engineers in particular to own the cost optimization of their workloads, let alone operations teams inside of Kubernetes, because it is just different. So let's pull up Fairwinds Insights and let's walk you through what some of this looks like. So when you log into Fairwinds Insights, we're going to give you a dashboard that shows you across the organization a bunch of clusters and how well they're doing. So we give you a health score across the organization. There's a bunch of clusters running. We all have about the same health score here, it looks like. And I can click into any one of these organizations or any one of these clusters. I'm going to click on Proxima Prod, and it's going to bring up this dashboard that's specific to this cluster. Now I see a list of action items being introduced to the cluster on the top of the line and being removed from the cluster on the bottom of the line. We track a bunch of action items. So I'll show you what kinds of action items we get, but we're prioritizing them for you, because having a list of 2,807 things that you need to do, that's the ones that are passing, or even a couple of hundred that need being addressed is really overwhelming for ops teams. And so knowing what's critical, what do I need to go address right now, is something that we prioritize nailing down for you. We track that health score over time. We also have some cost management here, which is what we're here to talk about primarily today. I'm going to give you a high-level overview of the whole platform, but I'll spend some time on that cost management bit. So where is this coming from? We have a big list of action items, and this is, I guess I'll show you where it's coming from in a second. But in just one cluster, I can see all of the issues that are popping up. So the critical issues here are the issues that we need to go take care of right away. I can click on this and find out there are known CVEs running in my cluster. So this is things like when the log4j problem came out recently, that was a CVE that was reported. If you have that running somewhere in your cluster, this is the kind of tool that's going to alert you to that and say, hey, we know that there's things wrong running in this container. You need to update them because there's a vulnerability here. It's written in such a way that you don't have to be a very senior Kubernetes engineer to know how to go about solving the problem. And let's see. I did this a different way than I normally do. So I'm going to go back to my dashboard here. Let's see, clusters. I want to show you where all these reports are coming from. So in here we have an install hub where we can see all the different projects that are installed. So Polaris is an open source tool that Fairwinds has built that identifies common Kubernetes misconfigurations. This is one of our earliest projects in this space, just seeing that lots of people make the same mistakes over and over again. So we wrote a software tool to address that. You can write custom policy in Polaris, take the checks out of the box in Polaris, and you're going to be a lot closer to avoiding common mistakes. We also have Nova, which checks for out-of-date Helm charts, or Pluto, checking for deprecated APIs. But we've also married together a bunch of other open source. So Trivy, KubeBench, we have KubeSec, we have support for Open Policy Agent. And we also run Goldilocks underneath the hood for some of our cost efficiency bits here. So this is where all these reports are coming from. Now, if you saw that big, long action item list and you're overwhelmed, I get it. As a ops engineer, the last thing you need is a gigantic list of all the things you're doing wrong. You know there's some things wrong in your environment, so you want to be able to stop that beforehand. So when we talk about guardrails, that's what we're talking about, how you can write policy once and have it implemented everywhere, including CI at the admission controller level and at runtime in the cluster. So here we have an engineer who's pushing some new code into a cluster, and you can see Circle CI is failing it, but also Fairwinds Insights is failing it. And so in a workflow that an engineer already understands, working within something like GitHub, and it doesn't have to be specific to GitHub, you can do this lots of different places. You can just click details, it'll load you into the UI, show the engineer, hey, there's 5 action items, 2 are critical. You have to address these 2 critical items before you'll be able to deploy. And then things are going to improve over time because you as a platform engineer or whatever your title is have set the guardrails that your organization needs to meet, and your engineers are going to not be able to deploy things into the cluster without meeting those standards. And they're not going to have to come to you with every single question for what's the problem, how do I fix it, because we're going to expose that for you through Fairwinds Insights. So that's kind of a high level of what a bunch of the different things are. There's way more here, including the ability to compare clusters, to write custom policy, and to automate things like kicking something out to a Jira ticket in an automated way. There's a lot of ways to plug this in across your organization, make your team successful, integrations with Datadog, Slack, etc. But let's look at the efficiency tab, because this is where our cost and FinOps bits come into play. And this is what we're talking about today. So here across my organization, I get an overview of my clusters, what they're costing me. It's a quick glance at available CPU, total CPUs, et cetera, across my clusters. And you can do this across a 30-day average or something else. And we track that cost over time as a demo environment. So it's a little bit of a boring cost graph here, I guess, but we track that utilization as well. And then I can actually go into the workload level and again, select a specific cluster and see some fine-grained details about that cluster. So the daily cost, what each workload is costing me relatively across the cluster. And I'm going to go in here and look at the recommendations that we're giving. So in certain situations, Fairwinds Insights is going to suggest that you spend more money. And you can see that here in a couple situations where we're saying, hey, you're under-provisioned. If you can set the quality of service that you require. So if this is a guaranteed level that we need, we're going to suggest that you increase those resource requests and limits. If it's limited, if it's burstable, whatever, I mean, it's not always we're going to suggest that. I'm saying in this particular situation, we think it's under-provisioned given the quality of service level that you're looking for. And if you change that, it'll go down. But here, we see a workload that's we've marked as critical, and we think it's still over-provisioned, so we're telling you to spend a little bit less. You can click on that workload, get loaded into this, where we're going to show you this is the limit you currently have. This is the requests that you're making today. We think you should set your requests and limits over here at a different level. So down, if I can scroll, why is my computer all of a sudden not scrolling? There we go. So the average cost for this particular workload is $9.57. With our recommendations, it's only going to be $8.66. It's probably not worth making a bunch of changes across your organization in order to save you less than $1. However, at any kind of significant scale, this demo environment becomes, much more meaningful, and you can sort across the organization a number of different ways to see, what's the total cost, or you can sort by the cost with recommendations and see where you can save money significantly. So yeah, here. The cost difference with recommendations. So here's the workload that we're going to save the most on. You can sort right that way. There's a lot more here in Fairwinds Insights. This is just the beginning of showing you how this works. But if you're interested in knowing more, you're welcome to reach out to us. We'll have someone that can walk through it more specifically for you. And we have a question that came in, and we'll get to that in just a second here. Just did the demo, but let's wrap up with a poll here before I get to the Q&A section, and then we'll go from there. So what's the greatest opportunity to improve your Kubernetes environment? Is it all about saving money for you, or are you still just looking for help with getting started? Best practices across what you're doing currently, improving the reliability of your apps, or working on the security posture of your clusters? So if you take a second and fill that out. Do, 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 do. See, Rachel, this time you're supposed to sing. Do, do, do. Still need to work on my interpretive dance skills. I keep telling my daughters it's time for them to sit down and do this with me, but we never get around to it. We'll give that just a second more. Click a button. Tell us the greatest opportunity to improve your kube environment, so we have a feeling for that. This is metrics that we collect over time to see where people are with their Kubernetes situation. So yeah, saving money is the biggest one. Makes sense. You're attending this particular webinar. But yep, security and saving money. This tends to be where we see a lot of people struggling. So if you're wrestling with either of these, this is a place that Fairwinds plays. Reach out to us. We'd be happy to have a conversation with you. Our software literally exists to solve these problems. Let's wrap that up and jump into some Q&A. So we do have a question that came through. If others have questions, please type them in that Q&A tab, and we'll get to those. Okay, Robert, Rachel, you ready for this? Many companies think it's okay to spend extra money on the Kubernetes clusters running in production, workloads. Similarly, teams need to replicate similar infrastructure on integration or pre-prod side to ensure the deployment would scale and perform the same way as in prod before reaching prod. To me, it's a lot of money spent on a pre-prod environment. What are your thoughts on that? And how do you prevent making pre-prod environment as big of a black hole? Thanks.
Yeah, it's a really interesting question. We've done some of that, type of pre-prod load testing ourselves. We typically don't do it for like every single pull request or every single release. We just run it on a cadence. So maybe every month or every quarter, just to make sure that any big changes there are expected. And that's typically a much a smaller bill, right? Rather than having a perpetual staging environment that has, prod level traffic. We just have, we'll temporarily spin something up for a few hours, load test it, spin it back down. And that really contains the cost. Hopefully that started to answer your question. Do you have anything to add, Rachel?
No, I think that's a great point. Just, what's your risk to reward, I guess, tolerance for how much load do you want to put it under? And
yeah, I think the thing to keep in mind is,
go ahead, Robert.
Keep in mind is that there's no way to perfectly emulate production, right? You can fire a bunch of load at a staging environment just to see how it'll behave. But there's no way to just remove all the uncertainty of how things are going to scale in prod, how things are going to behave in prod. You can get closer and closer to that by spending more and more money, more and more effort on that testing. But it's always an imperfect science.
There's a reason that there are organizations out there that have made their names with logos or slogans like "I test in prod," right? Because that's being a little bit facetious or hand wavy. Obviously, you test before prod, but some things just can't be tested outside. Like you're always testing in prod, right? Anytime you're sending something into production, you're finding out, does it work in prod, and does it work at the scale, and does it work the way I think it works? Because you can test the heck out of it beforehand. And I would say one of the biggest differences here is what you're probably not doing in your pre-production environments is running it at the same size and scale as your production environment all the time. Like you might even spin it up to that big to see if it can work. I'm not sure that that's even super common. You're probably kicking the tires on individual services in certain ways, but there is a world wherein you spin up your pre-prod environments to be as big as production just to make sure everything's working, but you're not going to leave that on at that capacity and size all the time. And part of the beauty of Kubernetes is you can just scale it all down. So One of the ways to prevent your pre-production environment from becoming a black hole as much as production is install Fairwinds Insights on it. Costs you, it doesn't cost you much more to have it running in your dev environments, right? But have something that gives you an overview of all your clusters. And in theory, you're going to see that your pre-production environments are costing you less. And you want to know that. There's definitely times where we see development environments that are wildly over-provisioned. We have had organizations, we had an organization save $250,000 in a brief proof of concept with us. We've had organizations tell us they believe they're 900% over-provisioned. In Robert's example, they were only using 1% of what they had provisioned. So there's always, there's always ways to do this better, and good tooling is going to make it obvious and easy for you. So, are there any more questions? Let's see if somebody's said anything elsewhere. Yeah, Dave's sharing a link to the cost optimization white paper. I have that pulled up on the slide right there. If you want to go check out cost optimization in Kubernetes, we have a guide for that. It talks about everything from why it's hard to getting applications right-sized, and I'm sure that it also talks about our software. Look, there's a million ways to try to do this the right way. Call us, have a demo with us. We're probably going to save you enough money in the demo to make the time you spent on the phone worthwhile, and unless you have just like very, very little cloud spend. But if you're using Kubernetes at any size and scale, we're probably going to be a significant help. And with that, I will wrap up and hand things back over to you, Cody. Thanks so much.
Thank you, Kendall. And I'd also like to thank Robert and Rachel for joining us today, as well as Dave for adding in those that final link in the chat. So if you haven't had a chance to click on that white paper link, go ahead and do that while it's there. So I'd like to remind everyone that today's session was recorded. So following this panel, you'll receive an email with a link to access that recording on demand, or you can find the recording living on the DevOps website at devops.com/webinars, and just be sure to look in the on-demand section. So onto the drawing for 4 $25 Amazon gift cards. Our first winner is Edith B. Our second winner is Zhao V. Our third winner, Lior Y. And our fourth and final winner is Raphael A. So to our 4 winners, congratulations. Please keep an eye on your inbox to claim that gift card, but if you do not see that email, just check your spam folder. I would like to thank Fairwinds for sponsoring today's webinar. And of course, before we close, I'd like to thank you, our audience. We really appreciate you spending time with us this afternoon. We ask for just one extra moment of your time to fill out a brief post-webinar survey that'll pop up on your screen here in just a moment. But otherwise, we do hope to see you all at an upcoming Techstrong learning program. Everyone, have a great rest of your day. And Kendall, Robert, Rachel, thank you again.